Question number 4th says we have 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus dot 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 dot. So this here is T1, this here is T2, this here is T3, and what do we need? We need TR. Okay. I observe in the denominator you have product of two numbers. T1 has 1, T2 has 2, T3 has 3. So TR will have 1 upon R. And the next number is just greater than this. This is 1 upon R, R plus 1. TR is this, right? How will we find this? So we cannot use summation over here directly. So the only approach to follow here is by writing this as difference of two terms. Okay. A concept called partial fractions is discussed in class 12th in the chapter integration, right? In this NCERT discussion, you will find integration, and there's a concept called partial fraction which has been discussed over there. But the important thing to understand this particular question is, I want to write this as difference of two terms with the idea of partial fractions without actually mentioning partial fractions, right? Without actually mentioning use, because NCERT people have used this, they haven't mentioned partial fractions. How will we use it, right? How will we write it? TR. If you have this R, R plus 1 over here. So you have consecutive terms over here, right? Consecutive terms, okay. In the numerator, erase this. In the numerator, I'll need to multiply with something. What is that? This is the last term, first term. Last and first. Take this last term over here and first term over here and subtract. What did you just do? You just took the last term and the first term, took the difference. Okay, so what are we actually trying to do over here is this. That we want to multiply with R plus 1 minus R. Last minus first. When you have consecutive terms in the denominator like this. R plus 1. Had there been R plus 2, you would be taking R plus 2 minus R. Last minus first. You multiply with this and R plus 1 is already there in the denominator. What have you actually multiplied with? R plus 1 minus R is actually 1. So you multiply with 1, divide by 1. Now dividing by 1 is redundant, right? That's not an issue. But the beauty of writing this in this manner is that TR will now simplify to this one is not upon R plus 1 upon this is 1 upon R minus 1 upon R plus 1. This is important. This particular form is important. Once you write TR in this particular manner, now, can I find the summation easily? Yes. T1 will be 1 upon 1 minus 1 upon 2. T2 will be 1 upon 2 minus 1 upon 3. T3 will be 1 upon 3 minus 1 upon 4 dot dot dot. Tn will be 1 upon n minus 1 upon n plus 1, and you can add all of these. You can add all of these. Sn, which is T1 plus T2 plus dot 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 plus Tn, which will be equal to sum of all these terms. When I take a look at these terms, what do I see? This 1 by 2 gets cancelled with this. 1 by 3 gets cancelled with this. So 1 by 4 similarly will get cancelled with something over here. And this 1 by n will get cancelled with something over here. Yes. So this is equal to this term 1 by 1 minus this 1 upon n plus 1. This is what you get. Right? Therefore, Sn is 1 minus 1 upon n plus 1, which is n plus 1 minus 1 upon n plus 1, which is n upon n plus 1. This is Sn for us and the complete approach for solving this kind of a question. Sn is n upon n plus 1. That's all. Is there anything important in this? Yes, this is the most important thing, and this is very, very useful. Had there been R plus 1, R plus 2, so last term will be R plus 2, we'll take R plus 2, we'll take R, subtract them. In the numerator, what remains is 2, so you multiply, you have actually multiplied with a 2, you divide with a 2. So this will become 1 upon 2 in that case, right? And that's all in this fourth question, as you can see over here.